Hello class, I hope you are doing well. Today I would like to complete one of the practice problems from chapter 6, and this problem goes over uniform circular motion. So let's go ahead and get started. An athlete whirls a 7-kilogram hammer from 1.8 meters from the axis of rotation. In a horizontal circle, if the hammer makes one revolution in 1 second, what is the centripetal acceleration of the hammer and what is the tension force in the chain? So let's go ahead and create a column of knowns and unknowns and then draw a picture to help us solve the problem. So the mass of the hammer, so I will use a subscript of h, so m sub h is 7 kilograms from 1.8 meters, so the radius that the hammer is being spun is 1.8 meters, and the time period is 1 second, so it makes a complete revolution every second. It wants us to calculate the centripetal acceleration of the hammer, and this is A sub C, and then the tension force in the chain, so force of tension. Now, before we can calculate the centripetal acceleration of the hammer, we're going to need to calculate the velocity of the hammer. So that is an unknown, so I'll put that there too. Now, to draw a simple picture, if we had a top view of this situation, and we have the hammer here, and we have a chain, and this is spinning in a circle here. So we have a top view, and here in the center of the circle is the axis of rotation. So if this were in 3 dimensions, you would be able to see this axis of rotation coming out of the board here. Okay, so to start this off, we're going to calculate the velocity of the object. Now, in order to calculate the velocity of the object, we need the displacement vector. And so for one full rotation around this circle, we know that the displacement vector is the circumference of the circle. So we have the circumference divided by the time period, okay? The circumference can be calculated 2 pi r, okay? And so in the numerator, we need the radius. The problem gives us the radius, 1.8 meters. So what we have is 2 pi times 1.8 meters, and we're going to divide this by 1 second. So 2 times 1.8 is going to be 3.6 meters. So we have 3.6 meters times pi divided by 1 second. So let's grab our calculator. So 3.6 times pi gives us 11.31, and we have units of meters here, and we're dividing this by 1 second, so this is going to be 11.31 meters per second. Okay, now this is the velocity of the hammer. I'm going to copy this down here to save some room. Now we can calculate the centripetal acceleration of our hammer. So centripetal acceleration is identified by A with a subscript of C. This is going to be the velocity squared divided by the radius. Now for the velocity, we just calculated this, so we're going to use our calculated value, 11.31 meters per second. We're going to square that value and divide by 1.8 meters. Okay? Now, according to the order of operations, we're going to have to take care of the squared first. Remember, not only are we squaring our numerical value, but we are squaring the unit value. Okay? So 11.31 squared gives us 127.91. and we're squaring our units, so meters squared per second squared. We're dividing this by 1.8 meters. This gives us 71.06. Now let's take a look at our units here. So our units in the numerator are meters per second squared. Meters squared per second squared. We're dividing by meters, which algebraically is meters over 1. And so this is going to be meters squared per second squared times 1 over meters, because we're multiplying by the inverse of the denominator here. One of our meters is going to cancel, leaving us with units of meters per second squared. So our centripetal acceleration, 71.06 meters per second squared. Next, we need to calculate the tension force in the chain. So we know our velocity vector points tangent to the circle, and our net force vector points towards the center of the circle. And this net force vector, this net force causes the centripetal acceleration. So the hammer is always going to be turning toward the center of the circle. So it's known as center seeking or centripetal acceleration. Okay, and we've calculated that right there. So the net force vector points to the center. This is the agent is going to be the tension force. So the force of tension is equal to the product of the object's mass and the object's centripetal acceleration. So the mass is given to us in the problem at 7 kilograms. And the centripetal acceleration is equal to 71.06 meters per second squared. This gives us 497.4. Now let's take a look at our units. We have kilograms, which can be written as kilograms over 1 times meters per second squared. And this gives us a kilogram meter per second squared. And we know that 1 kilogram meter per second squared is equal to 1 Newton. So our units are newtons, and this is the force of tension. And that is our answer for the force of tension calculation. I hope this video has helped you. If you have any questions, feel free to give me a call or feel free to send me an email. I would love to help you out. I hope you have a great day.